Hello students, today we'll discuss 9 to 16 exercise problems of first chapter of physics, electric charge and fields. Let us start. In ninth one, we have a system of two charges. QA is equal to 2.5 into 10 raised to minus 7 coulomb and QB is minus 2.5 into 10 raised to minus 7 coulomb. Given they are at position 0, 0, minus 15 centimeter and 0, 0, plus 15 centimeter respectively. What are the total charge and electric dipole moment of the system? So we are asked to find out two things: total charge of the system and dipole moment. So data is here. We denote position vector of A to be RA and position vector of B to be RB. Okay, and Q we are asked to find out. Q is total charge and dipole moment. So as far as first question is concerned, how much is the total charge? So total charge of dipole is always zero. Two charges QA plus QB, but it is not actually needed. When you are given dipole, total charge is always zero. Now how do we find out dipole moment? So we know that dipole moment is Q into 2A. So when you have two charges, you should be knowing that what is 2A. 2A is direction as well as the magnitude of distance between two charges, so resultant vector you may say. So in this case, as the negative charge is QB, the direction of dipole moment is from B to A. Okay, and hence if we look at the formula, P is equal to Q into 2A. Now Q is 2.5 into 10 raised to minus 7. It is simply magnitude, not plus or minus. Just put value 2.5 into 10 raised to minus 7 for Q. How do we find out 2A? So is it okay if I write A is equal to RA minus RB? So this is wrong because 2A itself is the resultant vector of B and A and not 2A, not half of that. Okay, so distance between B and A is 2A, not half of it is A. So be careful there. When you take RA minus RB, it is 2A itself. What if I write 2A is equal to RB minus RA? Now here also there is one problem. When you are finding out direction of dipole moment, you should take final minus initial. So you are going from B to A. So A is final, negative charge to positive charge we are going. So B is negative charge, positive charge is A, and hence we are going from B to A. A is final, B is initial. So this is also wrong. And 2A is equal to RA minus RB is the expression. Okay, so we have RA. We have RB, okay, RA and RB here. So substitute in this equation. You will have 2A. Use it in equation 1 to get dipole moment. Okay. In 10th one, we have an electric dipole with dipole moment 4 into 10 raised to minus 9 coulomb meter aligned at 30 degree with the direction of uniform electric field, and field intensity is 5 into 10 raised to 4 Newton per coulomb. Calculate the magnitude of the torque acting on the dipole. So what we are given, dipole moment P is equal to 4 into 10 raised to minus 9 coulomb, coulomb meter actually, and theta is 30 degree. Electric field is also given 5 into 10 raised to 4 Newton per coulomb. What we are asked to find out? Torque. Okay. So what is the formula for torque? We know that torque is P cross E or else PE sine theta. If you want direction, take P cross E, but here we are given magnitude. So we will go for PE sine theta. Substitute values. In 11th one, we have a polythene piece rubbed with wool is found to have negative charge of 3 into 10 raised to minus 7 coulomb on it. And we are asked to estimate the number of electrons transferred from which one to which one. Electrons will be transferred from polythene to wool or wool to polythene when we rub the two. One more question is there any transfer of mass from wool to polythene or polythene to wool? So here we are given charge 3 into 10 raised to minus 7 coulomb, and of course the charge on one electron, that is 1.6 into 10 raised to minus 19 coulomb, and what is the mass of one electron. So how do we approach this? Total number of electrons we are asked to find out, and how much is the total mass transferred. So what to do? So we know that if I have 1.6 into 10 raised to minus 19 coulomb charge for one electron, 3 into 10 raised to minus 7 coulomb charge of how many electrons? So I can always find out number of electrons with this formula. Okay, and now we are told that polythene piece have negative charge. It means that electrons are going from wool to polythene, isn't it? So electrons, if are transferred from wool to polythene, polythene is getting negative charge, polythene is getting mass of this many electrons. So once you have n, you can say that is the mass transfer. So once we have number of electrons n transferred, we can find total mass also, because one electron 9.1 electron is of 9.1 into 10 raised to minus 31 kg, then total number of electron is how much mass. So you should be able to find out total mass transferred also. In 12th one, we have two insulated charged copper spheres A and B, and have their distance centers separated by 50 centimeter distance. So what is the mutual force of electrostatic repulsion if the charge on each one is 6.5 into 10 raised to minus 7 coulomb? And we are told that the size of A and B is very small as compared to distance between the two. Apart from that, we are also asked what is the force of repulsion if each sphere is charged double and if distance is made half. So what we are given here, we are given charge on A and B, QA and QB both are same 6.5 into 10 raised to minus 7 coulomb. We are given distance 50 centimeter or half meter, and then we are told that charge is made double. So new charge if on A is QA prime and on B if it is QB prime, it is double of 6.5, that is 13 into 10 raised to minus 7 coulomb. And did we change distance? Yes, distance is also changed. New distance R prime is half of previous. Okay. So find out force initially and find out force after making change in charge and distance. So first one is easy. Simply apply scalar form of Coulomb's law. See, K we are supposed to know, QA, QB and R. Everything we are given, we should be able to find out first answer. For second one, you can take F prime to be K QA prime QB prime upon R prime. What is QA prime? QA prime is double of QA, QB prime is double of QB, and then R prime is R by 2. So you can substitute values and you can find out. Other option is simplify this, take constant outs. Then you will have some 4k QA QB by R square or 8 QA QB by R square or 16 QA QB by R square, something you will have. Because R by 2 on squaring will give you R square by 4. This 2 and this 2 of QA and 2 of QB can be taken out. Then ultimately you will have some constant into KQA QB by R square, which is result 1. So better way of doing it is not substituting values here, but instead simplify this and take ratio. Okay, try out whichever way you are comfortable with. Suppose the sphere A and B in previous numerical have identical sizes. A third sphere of the same size but uncharged is brought in contact with the first and then brought in contact with the second one and finally removed. What is the new force of repulsion between A and B? A bit tricky problem it seems. First of all, why identical sizes? Does it make any difference if size of A and B different? and then third sphere of same size is first put in contact with A, removed, then put in contact with B, removed, and then we are asked to find out what are the changes in A and B so that we can find out force. Let us try to understand the problem first. So consider this to be A and B, and let the distance between the two to be r. Now we are told in previous one that charges on A and B are same, so we assume the charge to be q and q. Okay, and in this case, how do we find out force between the two? So we know that force is simply k qa qb by r square, and if charges are same, you don't need to write qa and qb. You can simply write q and q, and hence you have k q square by r square. Very simple. What next? Now we are told that a third sphere of same size but uncharged is brought in contact with the first one. So what will happen if I take first sphere, say A, and if I put it in contact with another uncharged sphere? What do you think will happen? Now obviously this one is having no charge on it, and so it will take some charge from Q. Now how much charge? Q by 2, Q by 2. So q by 2 is the case when spheres are identical, not always. Suppose if charges are spheres are not of same size, the distribution will not be equal, and so this identical size is very important part of question. If the sizes are not identical, the distribution will not be equal. Okay, so luckily here the spheres are identical, and so now the A is possessing q by 2 and not q. Okay. Now the third sphere is having q by 2 charge, and now if we put it in contact with this one, what will happen now? Now say this one is having 1 q and this one is having half q. So what is the total charge? Total charge on the sphere is 1.5 q, isn't it? And that 1.5 q will be distributed equally between the two. So what is the half of 1.5 q? Will be here. The other half of 1.5 q will be here. That is 0.75 q, 0.75 q, or else you may say 3 by 4 q. So each one will have how much charge? 3 by 4 q, 3 q by 4 you may say, and that is the new charge on B. Okay, and now if the distance is same, what will happen? Here I am considering distance to be same. So what is the force? This is the force, and now as I said that you can simplify it further, so you will have this 2 and 3 by 4 outside, so 3 by 8 you will have, and then you will have k q square by r square, which is F. So you can say that new force is 3 by 8 times previous force. Okay, now this particular problem may also have many variations. Okay, so understand the process. In 14th one, we have a figure given, and as we can see in figure, we have positive charge, negative charge. So you have electric field downward, and from this electric field, three particles are allowed to pass. So third particle, as we can see here, is going down. First and second are going up. And in this situation, we have some question given. Give the signs positive or negative of three charges. Which particle has the highest charge to mass ratio? Now, no numerical values we are given. How do we decide? So, first of all, we know that if first and second particle, if they are deflected in upward direction, we should be able to understand that these two should be negative charges, isn't it? Then only you can say deflection towards positive charge, affinity or attraction towards positive charge. Now third one has deflected more, and that also in downward direction. How do we know more deflection? So you can look at the angle of deflection. Ideally it was supposed to go straight, but because of electric field, it got deflected by this angle. Okay, which is not the case with first and second. In first and second case, if you look at the angle, this angle is smaller, both in case of first and second. So you can say that deflection suffered, or the third particle underwent more deflection as compared to first and second. So one thing is for sure, that third is positive particle and first and second both are negative particle. Now if you look at this expression, F is equal to QE, what we can understand from this is that if charge is more, force is more. And if I simplify it further, if I take it as F is equal to ma, and if I compare it with QE, I can say that Q by m, charge to mass ratio, is E by A. So this is how we can find out charge to mass ratio, and which one of the three is having more deflection, third one. So I can say that if charge is more, say electric field is same for both. So if charge is more, then only force will be more. Okay, so third one should have more charge to mass ratio. In other words, you may say that third one must be lighter particle so that it got deflected more. In 15th one, we are asked to consider a uniform electric field E with 3 into 10 raised to 3 Newton per Coulomb intensity in positive x direction. What is the flux of this field through a square of 10 centimeter side length, and which is along YZ plane? What is the flux through the same square if the normal to its plane makes 60° with x-axis? So first I think we need to understand the situation. What do you mean by YZ plane, and what is the orientation of the plane with respect to electric field? So electric field we are given, and now if I consider Cartesian coordinate system, we know that surface here is along z and x direction. So this surface or this plane is regarded as xz plane or zx plane, and this is the area vector of xz plane. Area vector is always perpendicular to the surface, so I can say that if plane is xz, area vector is along y direction. But we are asked to consider, what about this surface? So this surface is in xy plane, so this is xy surface or xy plane, and its area vector will be along z direction, but I want yz plane. So my surface is here, okay, and what is the direction of area vector? This one, okay. So what is the angle between area vector of this plane and x-axis? Area vector is along x, and our electric field is also along x, so angle between electric field and area vector is 0 right now. And in this situation, if I am asked to find out flux, what is the formula for flux? I have mentioned area here directly because square of 10 centimeter side length. So area will be 10 into 10, 100 centimeter square. Be careful, it is centimeter square. And this is electric field. So how do I find out flux? Flux is EA cos theta. So in this case, angle between E and A is 0. So cos 0 is 1. So simply just take E into A. So 3 into 10 raised to 3 multiplied by 100, but it is in centimeter square. You will have to convert it into meter square. As far as B is concerned, when the angle is 60 degrees, so when the surface is tilted, just this theta value will be 60. So you will have A into cos 60. Okay, so you can substitute values and find out flux linked in both A and B case. Again, be careful about centimeter square, and don't forget to mention unit of phi at the end. And again, there are many possible twists of this problem. You can be asked for xy plane, you can be asked for xz plane. Okay, instead of 60 degree, you may be told that the angle is 45 degree or 30 degree or 180 degree. Okay, so think about the possible solution if the values are changed. Last one of today's session, 16th one. What is the net flux of the uniform electric field of exercise problem 15 through a cube of side length 20 centimeter oriented so that its faces are parallel to the coordinate planes. So what do you mean by faces are parallel to coordinate plane? So we have to consider a cube made up of xy plane, yz plane and xz plane, and then the same electric field we are given, and cube is bigger, slightly larger, 20 centimeters is the side length. So now what happens when we place cube? So this is my first surface xz, second surface xy, third surface xz, and now if I want to make cube, I'll need to add 3 more surfaces. This is the electric field, and this is first surface opposite to xy, second one on top, and third one here. What we are asked, the side length is 20 centimeters. What we are asked, what is the net flux? Now what happens here? The number of field lines entering this cube will definitely be leaving. Okay, so if 10 field lines enter from left side, 10 will be leaving from right side. So what is the net flux linked in this case? In this case, net flux will be 0. Uh, any closed surface will have 0 flux when there is no charge inside the surface. If there is charge inside the surface, then sigma q by epsilon 0. Okay, so there are two possible explanations here. One is, you may say that field lines entering and field lines leaving both are same, both are equal number wise. Or else you may say that this cube is not enclosing any charge, and hence according to Gauss's law, phi is equal to sigma q by epsilon 0. Sigma q is 0, and hence flux linked with this cube must be 0. Okay, so that is all for now. Thank you.